bonds will have higher percentages and bond angle is higher. Percentage S is more, bond length will be lesser, right? Okay. Now applications we have not started, I guess. Okay, right now, first application. Carbon hydrogen bonding. Carbon hydrogen bonding in CH3F and CH3Cl. Compare करें. Do it yourself. Don't see it. Carbon hydrogen bonding in CH3F and CH3Cl. CH3F, CH3Cl. You have done? Yeah. Okay. What is the answer?
CH3Cl.
Why?
Because
Just read the statement of pencil once again.
So let's ask that.
So CH3F, fluorine is more electronegative element. Now just look at this rule. More negative element, percentage S is less. So if towards fluorine side it is less, other side it will be more. See, overall value of percentage is fixed, right? It can't be like, you can't say sp3 will become sp4 or something, right? If fluorine side percentage S is less, the other side it will be higher. Is this logic clear? CH3F, carbon is sp3. Fluorine has slightly lesser percentages. So hydrogens will have slightly higher percentages. Same, chlorine has slightly lesser percentages. Hydrogen will have slightly higher. But when I compare fluorine and chlorine, fluorine has relatively much lesser percentages. So hydrogen on other side will have slightly much higher percentages. So their bond length will become short. समझ में आ गया? अब इसको लिखो ही जाने. All you right.
So F is more electronegative. That's why.
Right on like this. Very good. F is more electronegative. So towards fluorine, percentage S will be lesser towards fluorine. Percentage S will be lesser. Due to this, towards hydrogen, percentage S will be more because CH3F we are talking about, no? So F के side में अगर कम हुआ तो उधर बढ़ेगा भी, right? Because overall it has to be matching with the actual numbers. So towards hydrogen it will be more. High percentage S means shorter bond length. So CH bond lengths will become little short. Exactly same thing happens with chlorine, but the impact of fluorine is much more higher. Hence CH bond will be much more shorter in fluorine as compared to chlorine. क्या पूरी बात समझ में आती है? लिख लीजिए एक पूरा नोट कर लीजिए. Because then many things will be based on this itself. Right? Shyam, is it clear to you?
Yes, sir.
All right. So which one should have higher bond length, Shyam? CH3Cl or CH3F?
Sir, CH3N.
N नहीं, CH3F और CH3Cl दो ही ऑप्शन है, N तो ऑप्शन में नहीं है.
CH3Cl, sir.
CH3Cl. Reason being, समझ में आया? Chlorine pulls more. So as compared to chlorine, fluorine pulls more. So hydrogen side it will be much more bigger value in fluorine, much more shorter bonds in fluorine. Understand? Next question. Question number 2. Compare CH bond length in CHCl3 and CHF3. कैसे करोगे? Compare CH bond length in CHCl3 and CHF3. CH bond length will be lower in CHF3 you are saying. Will be more in CHF3 you are saying. Okay, why?
Because if the HF bonds are shorter than HCl bonds, then the CH bond would be longer in CHF3.
Think once again. Fluorine is non-electronegative. Okay, go to the previous question once again. Previous question, CH3F. our answer was CH was longer in CH3Cl. That's what we wrote in the last case.
Yeah. Yes.
So this time also the same thing, no? It is CHF3, CHCl3. More fluorines and more chlorines, right? So why will answer change? You get the point?
Yeah.
It's the same question actually. Only thing is like now we have 3 fluorines, right? So answer is CHCl3 bond length is 1.78 angstrom. You can note down like this, draw the structure. You can say percentage S is higher than 25% in CHCl3. Percentage S is much higher than 25 in CHF3. Make sense? And eventually the bond length comes out as 1.78 and 1.75 angstrom.
So we have to know these ones.
Yeah, please note down this whole thing. Just for record. Okay. No need to remember it, but you can just note down this exam. Draw the structure. Write whatever I have written. Write the values in bond, what do you call distance, bond distance. Again, these things will become more important for advanced point of view. So, not very much for your board exams. I don't think school teacher has discussed these things. Have they discussed? Yeah. So, in school, definitely not. In JEE Mains also, not very much possible. These are my questions. Mostly for advanced physics. कर लेंगे कोई भी प्रॉब्लम्स भी कोई भी दिक्कत अच्छा जी now answer one more question, just write one more question below this, and I think you are noting down these are questions Q1 Q2 Q3 Q4 like that. Keep continuing the same sequence. CHCl3 and CHF3, which one is more acidic? CHCl3 and CHF3, which one is more acidic?
Yes,
Is more acidic.
Sir, CHF3.
इसको भी चल रहा है पीछे जाके चेक कर रहा है.
So more percentage as more acidic.
Yeah, so CHF3. Like bond length wise also longer bond length becomes more acidic, no, because H.
So which one is longer?
CH bond over. Wait, what? No, wait.
You've done back bonding?
Yeah.
Go to back bonding lecture. रिवाइज लीजिए आप लोगों ने स्टार्ट पे. बैक बॉन्डिंग पे जाइए. वहाँ पे क्वेश्चन किया था आपने CHCl3 वर्सेस CHF3. ये नहीं.
Yeah.
Which one is more acidic?
No, this maps on.
Correct. Just go to this page. देखा है ठीक से नहीं लिखा. Which is more acidic?
So
CHCl3. चेक करो नोट्स अपने अपने नोट्स में लिखा है आपने. CHCl3 वर्सेस CHF3 लास्ट क्लास में लिखा है. आफ्टर क्लोरोफॉर्म फॉस्जीन वहीं पे लिखा है. चेक द नोट्स. है ना? यहाँ पे कहीं हो. See which one is more acidic. CHCl3. Can we apply the same logic here also? So that logic gives CHCl3 is more. So of course like it can't change. Here also we can say the same thing because CH bond length is longer in which case? CHCl3. If a long bond is given, that can be broken easily. अब CHCl3 आप easily break कर पाओगे? As compared to CHF3, तो acidic कौन सा ज़्यादा हो? Shyam, which one is more acidic?
So what was the question I dropped?
Versus CHF3, which one is more acidic?
So CHF3.
CHCl3. Because CH bond length is higher. Okay. And even with the logic of back bonding, if I remove H and keep C negative, the minus charge is more dispersed in Cl's vacant orbital. 2p pi, 3d pi याद है आपको? p pi d pi bonding, back bonding, Electrons of P are dragged in vacant orbital of chlorine. All this things you have done in the
Because CH bond length is bigger and CH-Cl3, it can a loose acid tends to give, that's why it's more acidic.
CH bond can be broken easily. That's why it's a good acid.
Okay.
That is the approach of Bend's rule. If you want to explain the same thing with back bonding, you know the answer. Remove H plus, take the minus charge disperse to the chlorine vacant orbital. That way also it is more acidic. Is it clear? Chali, next question. Compare CHH angle, CH2 angle in CH2F2, CH3F and CH4. Compare bond angle CHH, basically HCH angle in CH2F2, CH3F and CH4. Kariye solve. CH2F2, CH3F and CH4. Tired? 11 to 1. जल्दी छोड़ दूंगा, टेंशन मत लो. बट अभी जितना पढ़ो अच्छे से पढ़ लो.
So CH4.
CH4. Right?
So it doesn't have any electronegative element.
So it is 109.28 degrees.
Yeah.
Now come to CH2F2 for example. CH2F2 case, there are two fluorines. Fluorine side percentage S is higher as per this rule, Bend's rule. Sorry, percentage is lower, fluorine side, right? So other side CH2 will be higher. Think fluorine side it is lower, so other side it will be higher. Higher means higher bond angle. If percentage S is more, bond angle will be higher.
CH2F.
समझ में आ रहा है? Yeah. What is the answer?
CH2F.
And what about the third one? एक और भी करना है. CH3F. ये कहाँ पे देखो?
Between.
Sorry? If you have two fluorines, other side two hydrogens, one fluorine, three hydrogens. So one fluorine percentage S will be lesser, two fluorines will be much more lesser. So other side will be much more higher. Can you visualize what I'm trying to say?
So you're saying CH1
What I'm
and
trying to say is,
CH2F2.
look at the structure. C, F, F, H, H. Electronegative element are on that side where percentage is less, right? ये देखा आपने? So this side percentage is high.
So bond
This
angle.
bond angle will be high. Okay. Make sense? If I remove one fluorine, can I say this will be reduced? So this increase will be slightly smaller. So this bond angle will be slightly lesser. Close आ जाएगा थोड़ा.
Yeah.
Is it clear? So now decide your answer.
So you want which has greatest bond angle?
Yeah, CH2 bond angle.
Sir,
Yes.
can't you use hybridization?
It is sp3 for all of them.
Yeah, just P3. So if this is,
You can't use hybridization.
both of these are negative, so they'll get back.
That's for electrons.
That electron will be pulled up, right?
Okay.
But hybridization is sp3 for all of them, right? My question is CH2 bond angle. See, sp3 gives me tetrahedral structure. If it is ideal scenario, it should be 128 degrees. But because of these groups, it will be slightly changed.
Okay.
And what change is there that we are trying to observe? See, if you just observe this change, it's not very big change. 1.75, 1.78 angstrom, right? 0.03 angstrom में ignore भी कर सकते हो आप. बोलो कि सब सारे bonds बराबर ही हैं, right? That you can say, but that is not making sense, right? So similarly, in this case also, your answer will be this right now.
CH2F2.
CH2F2 will be higher than CH3F and then CH4. Is it clear, Sanjita? Shyam, is it clear? Shyam,
Yes, sir.
is it clear?
Yeah, yes, sir.
What is clear? Explain. क्या समझ में आया आपको बताइए.
Sir, you just like the whole lecture or just
No, not whole lecture. Just this
Sir,
question.
only, sir, this so the bond angle you're just telling why CH2F2 has a greater bond angle than
Why?
So because F is more electronegative than hydrogen, fluorine.
Then
And then in the last one in CH4, all of them are the same, so it forms a tetrahedral structure. And
so just tell me about CH2F2 versus CH3F. How will you explain?
So in CH2F2, the bond angle between the two hydrogens will be maximum, but then between the two fluorines it will be less.
Why?
So because of the hybridization, the sp3 hybridization.
Mhm. What is Bent rule statement regarding fluorine and hydrogen?
So the angle decreases because of the fluorine and hydrogen.
So basically the Bent rule statement is, I repeat once again, electronegative element that side will be, percentages value will be smaller that side, okay? Just write down this. Now, fluorine is electronegative element, that side percentages will be smaller. Counter effect of this is, other side it will become higher. What is the other side of it? Hydrogen side. If hydrogen side it is higher and percentage is higher means bigger bond angle because of this logic. I think this we discussed. Percentage highest risk है 50% SP में angle कितना हो जाता है 180 degrees, right?
Then
That's PS time. So percentage is higher on other side means hydrogen side. Higher हो गया तो bond angle क्या हो जाएगा आपका HCH highest हो जाएगा. समझ में आया? Clear हो रहा है? Understand and then write. Otherwise, see, there's no point of we spending time in this lecture. So please pay attention. Ask your doubts if you're finding any difficulty. Is it clear, Shyam?
So basically,
yes.
So, like if you take CH2F2 versus CH3F, CH2F2 has 2 fluorines, so percentage S is even lesser than CH3F.
Exactly.
So that's why it's
Yes, towards fluorine side. So it is
H is higher.
higher on other side. Higher means the bond angles will open up. Simple सी बात है. Okay. So Bent rule application सीखना होगा. And if you are a serious candidate for advanced, these are very, very important questions. Trust me on this part, right? Next question, CF bond length. CF bond length. अभी CF bond length बताना है. CF, not CH this time. थोड़ा सोचना ध्यान से. CF bond length in CH3F, CH2F2, CHF3 and CF4. Correct.
CF4.
CF4. कार्बन के साथ 3 हाइड्रोजन 1 फ्लोरीन 2 हाइड्रोजन 2 फ्लोरीन 3 फ्लोरीन 1 हाइड्रोजन एंड 4 फ्लोरीन. कंपेयर करो. ट्राई. बॉन्ड लेंथ CH नहीं है, सो आपके पास दो ऑप्शंस हैं. ऑप्शन 1, आई अज्यूम दैट द क्वेश्चन इज CH बॉन्ड लेंथ. व्हाटएवर आई नो आई जस्ट अप्लाइड इन रिवर्स माय आंसर. ऑप्शन 2, यू थिंक originally from CF point of view and try to get the values. दोनों ऑप्शन आपके पास होता है. ठीक है? What is the answer?
CH3F is great. CH2F2
CH. Same order in which you.
Anyone else? Any other answers?
So I'm getting the same thing.
Huh?
I'm getting the same order.
Okay. So, which is longest bond length?
CH3F.
CH3F. The reason you are giving is hydrogen side it will be smaller.
Yeah.
So hydrogen side it will be longer. Fluorine side will be smaller. So highest will be CHF3. And then what about CF4?
So like basically more S percentage character, more bond length in perspective of CF. Right? If
More percentages for hydrogen.
S percentage character is inversely proportional to bond length for CH bond, and for CF bond or any electronegative element it's directly proportional. Right? Like more S character, more bond length.
Can say.
Right? For like Ca and any electronegative element. So
Yeah.
that part.
Okay. So which is highest?
CH3F
CH3F is highest.
is most S percentage.
How about CF4? Check CF4. CF4 में तो चारों ही फ्लोरीन्स है ना, हाइड्रोजन है ही नहीं, and they will all be at the same bond length. So CF का maximum bond length कहाँ पे निकल के आएगा? When it is CF4 alone, no hydrogen. Think. See, CF4 is a symmetrical scenario. So whatever is the CF bond length, that will be there. Now let's put one hydrogen this side. Okay. Keeping 3 fluorines. Now fluorine side percentages will reduce. Bond length will become short. As soon as H will come in play. Then I remove one more fluorine. One more H will come. Bond length will become even shorter. One more if I remove, it becomes shortest. So answer आपका ठीक है, but CF4 आप वहाँ पे miss कर रहे हो. Is it clear? CHF3 is fine, but the correct answer will be this. Just see. So number 1 will be CF4. Okay. How about CH3F and CH2F2 and CHF3? How are you going to place them?
So CF4, CH3F3, CH2F2, CH3.
Understand? समझ में भी आ रहा है? सर नोट मत करना please. समझ के लिखना please, right? And in case of doubt, you can please ask. Make sense? ठीक है. बहुत सारे और भी क्वेश्चन करने होते हैं, पर उतना नहीं कर रहा हूँ क्योंकि उतनी की रिक्वायरमेंट नहीं आपको as such. So we'll see few things in advanced prep only. Write down this question. In PCl3F2, ये क्वेश्चन है, ABC 3 पार्ट्स है. In PCl3F2, axial orbital length. Axial means ये वाला, vertical वाला, right? And equatorial, you understand, the planar thing. So in PCl3F2, axial orbital length is more than equatorial orbital length. Option A. In PBP, pentagonal bipyramidal, equatorial orbital length is more than axial orbital length. When I say orbital length, axial and all, take it as a bond length. Simply, right? That's a orbital length is what? It's a bond length, basically. And the third option is in PBP, trigonal bipyramidal, axial orbital length is more than equatorial orbital length. You have to tell me which option is correct, or is R correct. More than one option may be also correct. Try. You get the question? 3 options are given. You have to write these options and then decide which is correct option. आपका पोर्शन स्कूल के हिसाब से ठीक चल रहा है. स्कूल में आपका केमिकल बॉन्डिंग ही हुआ है, रेडॉक्स हुआ इसके बाद, राइट? थर्मो आपका शुरू हो चुका है, खत्म हो चुका है? स्टार्ट. तो अभी थर्मो भी आप कर ही रहे हो साथ में पैरेलल कंबाइंड बैच में, राइट? स्टार्ट पार्ट.
So we can start.
हाँ, आपका तो आगे ही चल रहा है.
Yeah, we can start.
Which section you are?
11.
Yeah, then
11A and
B.
तीनों लोग B में हो. और C वाला भी कोई है?
No, C is common.
अच्छा, C is commerce. A और B दो ही सेक्शन है. A वाले कौन कौन है आपके? और
so that's
Jiti and
Jiti and Chinmay.
चेन्नई
Hey Harika.
नहीं होगा चेन्नई. Sham is in
Yeah.
I'm also seeing.
Who is studying the answer?
नहीं studying answer.
I got A and C both.
A and C both, okay.
And I'm in this B section with it.
Okay. Others please
So
check.
what is PBP?
Pentagonal bipyramidal. ये क्या होता है? ऐसा लगा होगा ना? पढ़ा हुआ है क्लास में. 5 members, 1 of
SP3.
IF7, SP3D3.
D3.
ये जब नोट्स रिवाइज नहीं किया था, तो ऐसा फीलिंग हो कहाँ होगा? Please revise. हाँ? Triangle bipyramidal, PCl5. ये वाला structure.
So I don't track, I don't know.
Pentagonal we have done, no? Check it
I
out.
don't know.
SP3D3. 5 in a plane, 1 up, above, 1 below. चलो इसी वाले नोट्स आप देखोगे कम से कम अपने.
Yes, sir.
IF7. इन्हीं हाथों से लेकर
XCFs.
इन्हीं हाथों से लेके
One going pair would be there.
Yeah.
नो वन पे IF7 में कहाँ
No, no, XCS.
हाँ XCF6 करो सॉल्व. See, the first question is in PCl3F2, axial orbital length is more than equal orbital length. Meaning is very simple, that axial positions are longer than equatorial positions. You have to check whether this is right statement or wrong statement. How will you check? PCl3F2 structure you have to draw. How will you draw? Fluorine is electronegative, so fluorine should be top and bottom. Fluorine should be equatorial. Now, fluorine will be on which side? Where percentage is smaller. Electronegative is fluorine. Percentage is smaller means bond length are longer. So fluorine bond lengths are longer, right? Stretched. So is the first statement correct? And chlorine will come closer because of shorter bond length. Make sense? Is it clear? First statement is correct. Second statement, first correct, Akshay, Sham. So Sham also got A option, B option. Pentagonal bipyramidal, equatorial is more than axial. Now see, equatorial angles are 72 degrees. 360 upon 5. 72 degrees.
How will you have a pentagonal bipyramidal shape? Like if
It's this.
so, like on
One
your
on top, one
axial thing, you won't have any. Right?
No,
For
you have no.
PCL 3F2. So for PCL 3F1.
Yeah, PCl3F2 fluorine is axial. Fluorine are here.
So, but this isn't pentagonal bipyramidal.
This is triangle bipyramid.
Yeah.
Correct. The next question is not PCl3F2. Next question is a general pentagonal bipyramidal.
Okay. And what?
So pentagonal bipyramidal, what is this angle? 72 degrees. 360 by 5. Abhi 72 idhar hai and the vertical one is 90 degrees. So bigger angle means higher percentages. Other side is smaller percentages. क्या होगा answer? So
So equatorial bond and more.
Swatch है.
That's correct.
Equatorial will be higher than. So B is also correct. And C option. In TBP, axial is higher than equatorial. That also is correct, right? So answer is the ABC for this question. और ये J advanced का question. J advanced में आया हुआ question. Exactly word by word. Okay.
So
कर लोगे?
multiple option.
Yeah. So J advanced में single choice भी होती है, multiple option भी होता है. More than one options correct है.
JEE Main.
Only single choice. Done. So this is it about Ben's rule. Drago's rule. Have you done Drago's rule already? Right now? Drago's rule. छोटा सा ही. You can complete it quickly. क्या है ये Drago's rule? Dragons नहीं है. Drago नाम है उसका. Dragon मत बना देना please. Dragon's rule लिख दे रहे हो बच्चे. So Drago's rule is when central atom of the compound belong to third period or below and lone pair is present in inactive environment, that means lone pair is not supporting or taking or any other thing. Bonding takes place through pure orbital. Condition applied, electronegativity of SA means surrounding atom is less than equal to 2.5. पहले इसको नोट कर लो, सवाल पे कुछ नहीं आएगा इसको नोट करने से, then I'll explain.
So lone pair is present here.
Inactive environment. Just first write it down, then I'll explain everything. Don't worry. So once you'll write it, I don't think that you'll understand anything out of it. But lately, एक बार आपके notes भी complete होना जरूरी है. Once I'll explain, you'll understand everything. Don't worry.
And lone pair is present in inactive.
Inactive. What is meaning of inactive environment? अभी आपने थोड़ी पहले देखा back bonding, right? Lone pairs are trapped in the vacant orbital. Nitrogen lone pair are pulled in silicon's orbital, right? These kind of things are not permissible. These things are not happening. That means lone pair is not participating in any extracurricular activities. वो जहाँ पे वहीं पे it is not supporting anyone, it is not being dragged by anyone. That is called inactive environment. Is it clear?
So कहते हैं मतलब.
Yeah. First you write. I'll explain. Step by step.
The electronegativity of what's S?
Surrounding atom.
Oh, that's
Less than equal to 2.5. So I'll give an example now. What is ammonia's hybridization? sp3? What is the shape of ammonia?
Not it. It has one lone pair.
Regular geometry is tetrahedral, but the shape will be what? Trigonal pyramidal? Because of lone pair. Shah, is it okay? Is it clear?
Yes, sir.
So ammonia is trigonal pyramidal, right? Because of the structure of it. What is pH3 structure? pH3. N के नीचे आता है phosphorus and arsenic. So what is pH3's bond angle? Can you guess? Ammonia's bond angle is how much? With one lone pair it is around 107 degrees. Approximately 107 degrees. Can you guess PH3 is how much? चलो ऐसे आप बोलो कितना होना चाहिए सोच करो.
Sir, around 100.
100 होना चाहिए. और बाकी लोग बताएं.
Same.
Almost same. भाई वो 107 है.
Yeah.
उसी की फैमिली का मेंबर है. उसके जस्ट नीचे है. तो लॉजिक तो कहता है कि ऑलमोस्ट 107, 106, 105, 104 ऐसा कुछ होना चाहिए. Right? You'll get surprised to know that it is 94 degrees. Now who will explain this? 94 degrees is very close to 90 degrees. And if you just revise the valence orbital theory where we discussed that is a pure orbital and pure orbitals at 90 degrees angle only. So it is almost like pure orbitals taking participation. Okay. Then comes Drago's rule to explain this part. What is Drago's rule? Now we understand. Central atom of the compound belongs to third period or below. Third period कौन सा हुआ? Boron वाला period is second period. Below boron is aluminium, that is third period, right? Below carbon is silicon, third period. Below nitrogen is phosphorus, third period. Below oxygen is sulfur, third period. Below fluorine is chlorine, third period. Is it clear? Can you visualize third period elements? Below third period or below means अब उसके भी नीचे चले जाओ. You take phosphorus, arsenic, etc. And then the lone pair is present in inactive environment, as in lone pair is not participating anywhere. And the surrounding atom is having less than 2.5 value of electronegativity. For example, hydrogen. If I am talking about pH3, hydrogen is having minimum electronegativity 1 के आसपास पहुंच जाओगे और कम हो जाएगा, right? वो तो रेफरेंस हो गया, ठीक है, और नीचे पहुंच गया. So in that case, what can happen? This condition, there is no hybridization and bond angle is near to 90 degrees. This was the explanation of Drago's rule. So basically, what is happening when you have all these conditions fulfilled, hybridization is unable to explain the angles. It fails completely. It fails miserably, right? Hence, Drago's rule gives you a statement that ये हो तो भाई ये लगा लेना. Okay? If this is the condition, please apply this logic. So PH3, ASH3, SBH3, NPS, SB, and BIH3, all four of them are 94 or less, which to 91 degrees May, 92 degrees. Is it okay? So how to explain this? There is no hybridization. In this condition, there is no hybridization and bond angle is near to 90 degrees. Please note down. Now I understand all them. So first understand, then write down. And then I'll give you some examples to know in this regard. If somebody is asking, PH3 का hybridization बता दो. कई बार पूछ लेते teachers भी नहीं पता होता. So that's a wrong question. That's a wrong question. But अगर एग्जाम में ऑप्शन आ गया A, B, C, D, SP3, SP2, SP and none of these option नहीं है, तो मार्क दें. आपको मार्क करना पड़ेगा SP3. But please keep in mind Drago's rule. Frankly speaking, nobody should ask you hybridization of PH3. If somebody is asking, that means he does not know that Drago's rule is applicable, or the Drago's rule, right? So PH3 will not show any hybridization or no explanations given for that. Is it clear? Now let's see some angles. Ammonia is 107, PH3 is around 94. ASH3 is even lesser, SBH3 is even, BIH3 90, 91 के आसपास पहुंच जाएगा. Look at water. Water is 104.5. H2S is around 98 degrees. Drop of 6 degrees. Too much drop, right? H2S is even shorter, H2D even more shorter, right? So all these things, so somebody asking you H2S hybridization, you should not say SP3. That doesn't make any sense. You can say, as per Drago's rule, there is no hybridization. It is utilizing its pure orbitals, right? And that makes sense also to explain the angle of 98 degrees. Lone pairs will have some deviation, that's why the 98 degree angle we can explain. That is not exactly 90 degrees. Some changes are there. Is it clear? Please note down these values. When I say note down these values, ये क्वेश्चन भी एग्जाम में वैल्यू के साथ पूछ सकते हैं आपसे. So please note down the values also. ये स्कूल एग्जाम में भी आ सकता.
So what is BI?
Bismuth. Nitrogen, phosphorus, arsenic, antimony, bismuth. They are all 15th family member, 15th group member. Oxygen, sulfur, selenium, and tellurium. They are all, what we call it, 16th group member. कर लेंगे. Any problem with this? Thermo में कहाँ तक किया था हम लोगों ने? कहाँ तक कर चुके हैं? First, I think we have done isothermal. Isothermal के 5 से 6 cases right है last class में. We solved the question box. Next class we will start data static. ठीक है. Organic food representation बनाएंगे. Organic ये रखेंगे. और कोई चीज़ रखेंगे. अर्जुन डॉक्टर हैं. आपके वैसे काम कर रहा है. ठीक है. Anyways, so if you want to speed up your portions, you can do organic 9 to 10. और जहाँ पे बैठोगे समझ में आएगा. I'll ensure that. If you have time, please use it. So reason is organic आपके बैच में जब होगी तो आपके पास एक edge होगी. Most importantly, आपको पहले से आती हुई चीजें. So you feel more comfortable if you have time.
Sir,
Just see.
if I join, then I understand.
That's what. That I'll ensure that you understand. Okay. जिन्होंने कल भी ज्वाइन किया उनका ISMSM शुरू हुआ था मुझे पूरा समझ में आया. अर्जुन started from yesterday only. पूरा समझ में आया उसको. उसने आंसर भी दे भेजा है. सही आंसर भेजा है. So आप लोग भी ज्वाइन कर सकते हो. तो उससे क्या होगा थोड़ा पोर्शन और खिंच जाएगा. I'm not saying that I'll not do in this batch. I'll do in this batch also. But क्या है वो ऐसी चीज़ है कि आप 2 बार करोगे तो और समझ में आएगी. पहली बार करोगे तो कुछ समझ में आएगा कुछ समझ में नहीं भी आएगा. 2 बार कर लिया तो पूरा समझ में आ जाएगा. This is a fundamental for your 12th standard also. So you should spend more time. That time investment will pay a lot. Time bonding is done. ये कर चुके हो. Please check your notes. ये सारा हो चुका है ना? Back bonding. Okay. Bridge bonding भी हो चुका है आपके यहाँ. क्या बात है. तो सारी खत्म कर दिया आपने. Silicates अभी कराऊंगा नहीं. मैं बाद में कराऊंगा. Are you back?
Yeah, yes, I was here.
Let's start. Question number 1. Dative bond is formed in.
Sir, should we write?
Yeah, better you write because these questions are good questions. So I expect that if you write, you will understand. And these you can revise also later. Otherwise, अभी करोगे भूल जाओगे. Dative bond, basically that coordinate bond वाला arrow, is formed in protonation reaction. Protonation reaction, back bonding, Lewis acid and base reaction, all of these. What is the answer?
So what? Protonation reaction?
Water giving lone pair to H plus.
Oh.
Okay, anything giving lone pair to H plus is called protonation. Like H3O plus formation. So for example, write H2O, then O lone pair coordinate to H plus. It is protonation. What is the answer for the first question?
The A.
All of these.
All of
these. Protonation reaction, back bonding, sorry, dative bond बन जाएगा. Back bonding में भी आपने देखा lone pair drag हो रहा है. That is again arrow, right? You've seen. Lewis acid base nature, ammonia giving to BF3. That's also dative bond. Answer is all of these. So good question it is. Question number 2. Dative bond is not possible in. करो. Dative bond is not possible in. किसमें possible नहीं है?
Sir, I'm getting E.
How?
So because a carbon doesn't have a lone pair.
That's the right answer. Very good. Correct answer is E. Okay. First question your answer is D. Second question your answer is E. Because all other cases dative bond are possible. Look at P2H4. P2H4 P has lone pair can give to H plus. PH4 plus. PH3 has lone pair can give to H plus. N2H4 same as I've drawn P2H4 you can draw N2H4. Draw N2H4 give H plus lone pair. Draw water give it lone pair to H plus, right? So it is H3O plus. CH3 plus there is no such option. Very good shot. कर लेंगे. समझ में आ रहा है? पक्का? So draw these structures also. पिछले क्वेश्चन का लिखा ही नहीं.
Dative bond formed in
What's the answer?
the B's.
This one, what's the answer? What is the structure of P2H5 plus?
So we have P2H4.
That's what is. That's what I'm saying. Please draw. First you draw P2H4 and then take one lone pair and give it to H plus. कम लिखना चाहते हो? Save paper, save ink, sustainable development. एक साल के बाद, 2 साल के बाद कर लेना जितना करना है। अभी मत सोचो। Use as much as paper possible. Write as much as possible. Clear हो गया question आपको? Can you draw all these structures? Everyone, can you draw all these structures? Good. अगले question पे चलते हैं. Question number 3. Differentiate strong and weak bond. Differentiate strong and weak bond.
Van der Waals bond is weak.
Van der Waals bond is weak, okay. Then
The H bond is also weak.
H bond is also weak.
Covalent is strong.
Covalent is strong.
Ionic electrovalent is again strong.
Again strong. Coordinative
Strong.
and metallic.
Strong.
Yeah, so please note down the correct answer. Last two are weak. First four are strong.
So what is Van der Waals bond?
Van der Waals forces. Van der Waals forces are basically ion type. Let's say you take any ion, let's say Na plus, and you take Cl2, ClCl, okay, or you take Na plus and take HCl. So now when you bring Na plus closer to HCl, what will happen? There is a positive charge. So it will have affinity towards the minus charge, which is Cl, right? समझ में आ रहा है?
Okay.
Like this is called ion dipole force. Similarly, there are dipole force, dipole induced dipole force, okay, and induced dipole forces. Have you done this or not? Van der Waals forces नहीं किया आपने? Okay, then we'll do that also. But these are weak forces, okay? Van der Waals is weak, hydrogen bond is weak. Now you can say, sir, hydrogen bond is doing this much change in bond, like what you call boiling point. Now why it is weak? So see, the logic of weak is as compared to other bonds, it is just 5 kilocalories per mole energy, which is much more lesser as compared to other bonds. Right? Next question. Maximum number of lone pairs are present in.
Yeah.
Write the question. Maximum number of lone pairs are present in. Write the answer. संजना बताइए इसका आंसर. कैसे कितने लॉन पेयर्स हैं?
3.
एंड XeF4 में, XeF6 में,
1.
एंड फ्लोरीन के लॉन पेयर क्यों नहीं काउंट कर रहे हो?
Because it doesn't have electrons.
फ्लोरीन.
What's the total lone pair?
Have I written lone pair around xenon? ये भी तो lone pairs ही हैं.
Oh,
So it still wanted to be XEF.
no wait.
In XeF6, how many will be there? Two. You get the point? One lone pair इधर है, and each fluorine will have 3 lone pairs, no?
20.
You get the point?
No, 19.
So then, give me the answer. If the question is around Xe, your answer is correct. But I have not mentioned like that. I have written maximum number of lone pairs are present in. That's all. Nothing else is
The
written.
XEF.
So to count total lone pairs, right? What should be answer?
NCF.
समझ में आया? तो थोड़ा सा ध्यान से समझना है क्वेश्चन की लैंग्वेज क्या है. Don't have any prejudice कि अरे यही आंसर हो गया इसका, अभी देख लिया मैं तो. Okay. Next question. Total number of bond pair and lone pair in XeO2F2. Total number of bond pair and lone pair in XeO2F2. Sham, is it clear? Last question.
Yes.
Very good. You had your lunch?
Yes, sir. I had it before class.
Okay. Good. आप लोगों ने लंच नहीं किया? कर लिया? कब किया?
So
अभी
one-
बीच में दोनों में.
Yeah.
So you brought your lunch or you went outside?
But
Where?
Olympiad.
पार्टी चल रही है और क्लासेस होनी चाहिए. Total number of bond pairs. Good place, no? Total number of bond pair and lone pair in X0 to F2. Answer please. And please give me the right answer because आप morning कर चुके हो. So अभी वो learning phase से ऊपर नहीं पहुंच चुके हो.
Sir, C.
C. Okay. Others. Shyam is giving fastest answers, right? बाकी थोड़ा speed बढ़ा रही है.
Yeah.
C. Bond pair is समझते हैं bond एक bond एक single bond में दो pair मतलब that's a one pair basically, right? Double bond is two one pair, right? That way you count one pair and one pair. Count and give me the answer. Draw the structure of XZ to F2. How will it look like? XZ double bond O, one fluorine, one more fluorine, 1, 2, 3, 4, 5, 6, and one lone pair on XZ sitting there, right?
So you're counting this as a bond pair?
Yes, a bond pair. No? See, a pair of electrons forming a bond is bond pair. A pair of electrons sitting idle is called lone pair. Okay, so what's the answer?
So shouldn't it be the other way?
How many? XZ to F2. ऑक्सीजन पे इलेक्ट्रॉन्स चेक करो आपके ज्यादा हो गए इलेक्ट्रॉन्स आपने 10 इलेक्ट्रॉन बना दिए.
So shouldn't it be the other way the question?
हाँ बॉन्ड पेयर एंड लोन पेयर वाइज पक्का.
Yeah.
B.
So I'm getting 13 bond pairs.
सी 13 लोन पेयर कैसे?
So 1, 2, 3. 3 lone pairs, 3 lone pairs, 3.
Why?
Okay.
How many electrons are there? That's it.
3.
3, 3, 6, 6, 2, 8, 9, 10, and 11.
So
And,
D.
1,
D,
2,
no.
3, 4, 5, 6. बॉन्ड पेयर कितने मिले आपको?
6.
6. Okay. Shyam, your answer?
Sir, I had put 11 and 7. I put, yeah.
Answer is 11 and 6.
Okay.
Check it. Is it clear? Simple questions, but I think it is social is one right. Is it clear? Answer is 11 and 6. Shyam, is it clear now?
Oh, yeah, I got it right.
Next one. Which of the following follow octet rule, or which of the following follows octet rule?
BF3.
Follows octet rule.
So is this a multiple correct answer? So
Maybe
then,
multiple correct also. Let's check.
so NH, 3 and BF.
BF3 follows octet rule.
No.
Octet means 8 electrons, right?
Sir, only NH3.
Only
NH3, sir.
only NH3. So the problem with ClF3 is you have 3 chlorines.
Oh, okay.
So 3
Yeah.
chlorines means 6 electrons, and chlorine also has how many? 2 lone pairs. So 4 plus 6, 10 electrons over. SCl4 has a lone pair and 4 bonds. That means 4 into, see, each bond will be bond pair, no? Both will be 8 plus 2, 10 electrons. Ammonia has exactly 8 electrons, BF3 has less than 8 electrons. So the best answer is ammonia. Note कर लीजिए question. समझ में आ रहा होगा ये? Simple questions है. Next question. Which of the following follows octet rule? अब क्या करोगे? So now the perspective is different in this case slightly. This previous case, if you keep in mind, you can say ammonia is the answer for the last one. So this one is also ammonia. But if you read the question and see the options carefully, hydrogen has a problem of maintaining 8 members. Check. It is having duplet only. With that logic, CH4, NH3 and H2O cannot satisfy. PCl3 is the only thing which can have electrons because P73 में P बनाओगे 3 CRs बनाओगे, P पे 1 लॉन पेयर होगा, सबके 8 कंप्लीट हो जाएंगे. So with that logic, you have to mark the option and answer is D. But you have to think why. See, you have to take odd one out basically. Is it clear? That's why I'm not marking ammonia in this case. If you consider duplet also as a combination, yes, ammonia is an option. कर लेंगे? Okay. ठीक है, ये वाले कर लेना सारे क्वेश्चन. और थोड़ा सा और अलग क्वेश्चंस ट्राई करते हैं हम लोग. कर लो इजी क्वेश्चन. PCl5 में कितने इलेक्ट्रॉन्स हो जाएंगे? 5 वैलेंस में होता है इसका इलेक्ट्रॉन. And when you form 5 bonds, total how many electrons are around? 10 electrons. SF4 also 4 bonds and 10 हो जाएंगे. ClF3 3 bonds so 6 and then 2 lone pairs so 10. Please check. Can I say all these structures will be considered as hyperoctane structures? Doable? Can you complete yourself? Remaining? Come to the next question. Which of the following can complete their octet by dimerization? Last question is clear. Which of the following can complete their octet by dimerization? बताइए. डाइमर बना के ऑक्टेट कंप्लीट कौन करता है? ये है अपने क्लास में कराया मैंने. BCl2 कर सकते हैं और भी कोई कर सकते हैं. BH3 भी कर सकते हैं. BF3 नहीं करेगा because BF3 क्या बनाता है? बैक बॉटम. Okay. So complete their octet by dimerization. अब फिर से वहां पे फंस जाओगे. क्या है? फिर से वही बात आएगी. ऑक्टेट. BCl2 ऑक्टेट नहीं बन पा रहा है क्योंकि बेरिलियम में 8 नहीं हो पाए. कुछ भी कर लो. Is it fine? Okay. And then BH3 B2H6 बनाओगे तो 6 ही हो पाएंगे सराउंडिंग में. AlCl3 will be the best option. Okay. Structures आपने किए BSL2, right? I've done all these things. Yeah. Polymerization and all these things. Good. Yeah. Complete octet by dimerization. BF3, BCl2, BH3 and AlCl3. कुछ अच्छे questions हैं, इनको try कर सकते हैं. I think you already have assignment of chemical bonding. It has been given to you. Chemical bonding का assignment मिला आपको? नहीं मिला? नहीं मिला अभी तक. Not sure मैं मिला नहीं था.
Also like 200.
भूपेश, chemical bonding पे क्या क्या मिला आपको? Objective 1, Objective 2, Subjective 1, Subjective 2 ये सब मिला?
No, so we have that test.
Then we have to do questions on.
How many questions are there?
We
Sir,
did.
chemical bonding दिया है ना वो assignment?
Did you?
हाँ. Chemical bonding कितने questions? देखिए आपको. You have any sample? शायद देख के इनको याद है.
So we just got that one worksheet
Yeah.
that
Yeah.
did.
So we haven't done some of the stuff. Like
No, now you learn everything, no? No.
No, like aromatic compounds.
I don't want
Exactly come in organic.
There's some questions based on that with us.
Very-
But bonding में sheets आपको नहीं मिली आप बोल रहे हो. बाकी सारे sheets नहीं मिली सर. Answer this. Which of the following does not exist? Sham, what's your
B2H6 doesn't exist.
purview on this? Sheets are given or not? Chemical bonding. Did you get that?
So I have the chemical bonding sheets, yes.
Okay. How many questions are there in chemical bonding?
How?
How many questions are there in chemical bonding? Like the one you have right now.
Sir, I think there are some 200 maybe around questions.
कितने जमा नहीं है?
So I remember you had given it to us before our exam, and then Ashin sir had said that you can put all assignments on hold when you have.
Yes, sir.
But you have this, no? That's my
I
question.
think so, yeah.
ये बस.
Yeah.
Yes, sir, we have it.
Okay. कर भी दीजिए इसको कल. हाँ.
Yes, sir.
148 questions हैं. ये कल करके ले आएगा सारे. ठीक है?
Physics?
यही वाला पूरा 148 questions कल करके ले आएगा.
Physics class or क्या?
No problem. हाँ. अब लेके आ जाओ बस. जो भी क्लास है देख लेंगे. ठीक है? कल ही चाहिए मेरे को सारे. 1 सिर्फ कुछ नहीं होता. See, you have to read and mark. Which of the following is linear? I3 minus IN3 minus C2. पढ़ो आंसर मार्क करो. So 15 सेकंड में हो जाएगा क्वेश्चन. 148 into 1/4 is how much? 4 3 half an hour. 35 minutes. हाँ आंसर भी देख लेंगे. ठीक है, आंसर देख के भी करने में कोई दिक्कत वाली बात नहीं. करके तो लाएं. ठीक है, प्रॉपर सॉल्यूशन बना के लाएगा इसका. कल सबमिट करें.
So the whole thing.
वहाँ 148 क्वेश्चंस. अब एग्जाम खत्म हो चुके. 20 सेकंड क्वेश्चन. आंसर प्लीज.
So
So
B2
B-
F6.
B2 and B.
No, it's D. It's D.
Does not
Oh
exist.
yeah.
Yeah, it's D.
D. तो कॉन्फिडेंस से बोल रहे हो.
Then we are wrong.
Yes. B2 F6 and B2 CL6 बन जाएगा. B2 CL6 भी नहीं बनेगा. Okay. Next. Third loading here. This is a good question. Which of the following does not exist?
C5.
CS. Cesium. CSCl3. So you just observe I3 minus you've seen, right? I3 minus exists. That means correspondingly CS plus and I3 minus will form CSI3. So C can exist, right? So C cannot be answered. Like that you have to rule out other cases. So just note on the answer. Yeah. F3 minus does not appear, right? Yeah, does not.
So why?
Because fluorine cannot hold two fluorines and a negative charge on it. It's a very small size atom, right? So on fluorine, you can't put more fluorines further to form the structure. Others can have, right? Answer is count number of sigma and pi bonds in each.
So what is that?
Sigma and pi bond.
No,
So
what
the
is this?
structure.
So this नहीं समझ में आया अपने
Sir, what's a circle like? I know the
So is it
hexagon.
Resonance किया ना आपने क्लास में? You've done
Yeah.
resonance.
four?
Resonance means what? No.
So that's benzene. Right?
Yes. So resonance, you have drawn these two structures. I have shown that when you overlap these structures, what will be the result? It is showing conjugation all across.
Yeah. Oh.
The same thing is. Resonance, can we go? So answer please.
C2.
Benzene structure क्या है?
C6H6.
So draw the structure and count sigma and pi. फटाफट स्पीड में करो. C6H6.
The C, 3 by 6.
कैसी?
So you
So
have
it's like-
that.
कॉन्फिडेंस कहाँ से लाते हो इतना?
So you have this, right?
इतना कॉन्फिडेंस
So like this.
हाइड्रोजन भी लगाओ बेटा. हाइड्रोजन कहाँ पे लगेगा?
6 sigma 3.
6 हो गया. हाइड्रोजन भी तो है.
Sir, one H.
हाँ. So कितने सिग्मा कितने पाई में?